What is the decision boundary in machine learning decision trees? Have you ever wondered how machines make decisions? In the world of machine learning, a fascinating concept called the decision boundary plays a key role. So, what exactly is this decision boundary in the context of decision trees? Let's break it down. A decision boundary is essentially the dividing line or surface in the feature space that separates different classes or outcomes predicted by a model. When we talk about decision trees, this boundary is formed through a series of hierarchical splits based on the values of features. These splits partition the data into distinct regions that correspond to different class labels or predicted values. Now, let's talk about decision trees themselves. A decision tree is a supervised learning algorithm that uses a tree-like structure. Each internal node tests a specific attribute or feature, while branches representing the possible values of that attribute. The leaf nodes at the end of the branches representing the final classification or prediction. The decision boundary in decision trees is quite unique. It is piecewise and axis aligned, which means it divides the feature space into rectangular or box-shaped regions. This is done by splitting on one feature at a time. For instance, a decision rule might be, is feature X less than value A? Each of these splits creates boundaries that effectively separate the classes. Unlike other models that produce smooth or linear boundaries, such as logistic regression, decision trees create nonlinear and stepwise boundaries. This allows them to adapt to complex data distributions by combining multiple splits. During the training phase, the decision boundary is learned by selecting features and determining the best split points that separate the classes. Common criteria used for this selection include information gain or the Gini index, which aim to maximize class purity in each region. When it comes to classifying new data points, the decision tree follows the path of decisions from the root to a leaf node. This process helps determine which side of the boundary the new data falls on, allowing for accurate classification. In practical applications, decision boundaries in decision trees are interpretable and visually intuitive. This makes them particularly useful in fields where understanding the model's reasoning is crucial. For example, in healthcare diagnosis, credit scoring, or customer segmentation, being able to see how decisions are made can be very important. From the perspective of artificial intelligence and machine learning, decision boundaries also reflected how models categorize data. This can have implications for fairness and bias. If the training data is imbalanced or biased, the decision boundary may unfairly separate certain groups. Tools like ChatGPT, DALL-E, and Midjourney utilize different machine learning approaches, but they also relying on the principle of decision boundaries in their classification or generation tasks, often in much higher dimensional spaces. Productivity plugins that integrate artificial intelligence models depend on well-defined decision boundaries to provide accurate and relevant outputs. This highlights the importance of understanding how these boundaries form and affect predictions. So, in summary, the decision boundary in decision tree algorithms is created through a series of axis-aligned splits that partition the feature space into regions corresponding to different predicted classes. This allows the model to classify new data points by determining which side of these boundaries they fall on.